Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 9 students and the topic of discussion is circles. In this video, we'll be focusing on the solutions to the NCERT problems. In the first problem, we need to prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. So these two are congruent circles of the same radius. Their center is given by O and O dash, and these are the two chords AB and CD. They are subtending equal angles, so we need to show AB equal to CD. Now consider these two triangles OAB and O dash CD. OA is equal to O dash C and OB equal to O dash D, and these two angles are equal. These two sides are equal because of the radius of the circle. So these two triangles are congruent based on SAS congruence rule. So AB will be equal to CD by CPCT. In the next problem, two circles of radii 5 cm and 3 cm. This is 5 cm and 3 cm circle are intersecting at 2 points, and the distance between their center is 4 cm. So this AB is 4 cm. Find the length of the common chord. We know that this common chord will bisect the chord AB. So it is perpendicular to that. Now we will apply Pythagoras theorem to the two triangles ACD first and then BCD. Let the distance, chord distance be P, DC is P, and similarly below also it is P. So let us apply Pythagoras to this triangle ACD. So phi square will be equal to P square, and this distance is X, so X square. So that's what we have written, 25 equal to X square plus P square. So P square will be equal to 25 minus X square. Now again we apply Pythagoras to this triangle BCD. Now if this distance AB is 4 centimeter and if this is X centimeter, DB will be 4 minus X centimeter. So 3 square will be equal to P square plus 4 minus X the whole square. Solving this, there are two equations, we get 1 and 2, and the two unknowns are P and X. So solving two equations, we get X as 4 centimeter. Now substituting back this X here, so P square will be equal to 20 minus 4 square. So 16, 25 minus 16 is 9, P square is 9, so P is 3 centimeter. So what is the length of the common chord? Is 2P. So 2 into 3, 6 centimeter. If two chords of a circle intersect within the circle, prove that the segments of chord are equal to corresponding segments of other chord. So AB and CD are two chords intersecting at point E. We need to show that A is equal to ED and similarly C is equal to EB. This we need to show. Now perpendicular to the center bisects the chord. We are drawing a line OM. Now it is bisecting the chord. Bisecting means AM will be equal to MB. Similarly ON is perpendicular to this chord CD, so CN will be equal to ND, or we can write AM equal to half of AB. Similarly CN will be half of CD. Now we see these two triangles OME and ONE. We will try to prove them to be similar. These two angles are 90-degree perpendicular. O is common. OM is equal to ON. So by RHS criteria, right angle, one hypotenuse, this is the hypotenuse, and one side. OM and ON are sides. So these two triangles are similar. So ME will be equal to EN by CPCT rule. So now we see that ME is equal to EN. So we can combine now this one and we can combine two. So we can just, for example, I am just showing you AM plus ME will be equal to EN plus ND. So we can show that AE will be equal to ED. Similarly, we can show CE equal to EB. This can be shown like this: MB minus ME, MB minus ME. What is MB minus ME? MB is equal to CN, CN minus EN. So which is equal to EB equal to EC. So basically we are using the criteria 1 and 2. We are able to get AE will be equal to ED and CE will be equal to EB. If two chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angles with the chord. So these are the two chords which is intersecting at point E. Now from the center of circle, we need to show that the angles, let us draw those angles. OEN, OEN, this angle is equal to OEM, this angle. So we need to show these two angles are equal. So how do we do? Now we take these two triangles. 90 degrees is given because they are the perpendiculars. O is common. OM equal to OM, the radius of the circle. So these two triangles are similar. So by CP/CT rule, these two angles are equal. If a line intersects two concentric circles, concentric circle means circles with the same center. So this is the center O. We are drawing two circles with center O at A, B, C, D respectively. It is cutting. A line is intersecting at the 4 points A, B, C, D in the two circles. We need to show AB is equal to CD. So we will draw a perpendicular from here, OM. Now OM will bisect the chord. So if AD is the chord, AM will be equal to MD, AM equal to MD. Similarly, for the inner circle, BM equal to MC, BM equal to MC. So we subtract from these two. So AM minus BM equal to DM minus CM. What is AM minus BM? AM minus BM is AB. And this is CD. So AB is equal to CD. Three girls, Reshma, Salma and Mandip, are playing a game by standing on a circle of radius 5 meter. So this is a circle where Reshma is R, S is Salma, M is Mandip. They are standing, the distance is 5 meter. The circle radius is 5 meter and the distance is 6 meter. What is the distance between Reshma and Mandip? So we need to find this distance. This distance is given 6 meter. Radius of circle is 5. So let us draw. First connect the point O and S. Now in this triangle we will draw a perpendicular like this. So in this triangle we will try to find the distance OA. We'll find the distance OA. OA, how we'll get 4? This is 3. This is the perpendicular bisector. This is 6. RS is 6. So RA will be 3. This is 3. This is 5. So we'll apply Pythagoras theorem. 5 square minus 3 square will be equal to OA square, which is 25 minus 9, 16. So OA will be 4 meter. We can see that the quadrilateral ORSM, this is a quadrilateral taking the shape of a kite, because OR is equal to OM and RS is equal to SM. It is given, the two chords are equal. So it is the shape of a kite. We note that diagonals of a kite are perpendicular and the main diagonal bisects the other diagonal. So angle RNS will be 90 degree and RN will be equal to NM. Now we find the area of triangle ORS. This triangle will find the area, which is half base into height. This is the base. This is height, we found it as 4. So this is 6. So half into 6 into 4 is the area, which is equal to 12. Now we can also find area of triangle OS equal to half OS into Rn. Half OS into Rn. This is also perpendicular. So half OS. What is OS is 5, the radius of the circle. And Rn is we need to find out. So we need to find out Rn. We'll substitute half into 5 into Rn is equal to 12. So we'll get Rn equal to 4.8. Rn is 4.8. Now this is twice of this is the bisector. So Rm will be twice of 4.8, which is 9.6 meter. So the distance between R and M, Reshma and Salma, is 9.6 meter. In this problem, A, B, C are the points on the circle with center O, and such that angle BOC equal to 30 degree and angle AOB equal to 60 degree. If D is a point on a circle other than the arc ABC, find ADC. So how do we find this? Now take this segment. AC as the segment. Now how much angle it is subtending at the center? So it is subtending 90 degrees. This angle is 90. So this arc AC is subtending at the center 90 degrees. So how much will it be subtending at any other point? That will be half of. So this angle will be half of this 90 degrees. So angle ADC will be 45 degrees. In this problem, a chord of a circle is equal to the radius of the circle. Find the angle subtended by the chord at a point on the minor arc and also at a point on the major arc. So AB is a chord of the circle. OA is equal to OB, which is radius. So chord is equal to the radius of the circle. It is given. So OAB will be a equilateral triangle with each angle being 60 degrees. So this will be 60 degrees. This will be 60. This will be 60. Now AB is subtending at the center 60 degrees. So how much will it be subtending at the other point on the circle? So angle ACB will be half of 60 degree, which is 30 degree. So this angle will be 30 degree. Now we need to find this angle also on the minor arc. ADB also we need to find. So ADB will be half of this reflex angle. So this is 60. What is the reflex angle? 360 minus 60 is 300 degrees. So this angle is 300. So half of this will be 150 degrees. So angle ADB is 150 degree. Now in this problem, angle PQR equal to 100 degrees given, where PQ are the points on the circle with center O. We need to find angle OPR. This we need to find. So now we see that PQRS is a cyclic quadrilateral. The vertices of the quadrilateral are lying on the circle. So it is a cyclic quadrilateral and these two angles sum is 180 degree. We know it. So if this is 100, if this is 100 degree, this will be 80 degree. This angle is 80 degree. If this is 80, PR is common chord. So it will be subtending twice the angle at this. If this is 80, angle POR will be 160 degrees. So this angle will be 160. Now OP is equal to OR, radius of the circle. So these two sides are equal. So angle OPR and angle ORP will be equal. So these two angles are equal. If this is 160 and the sum of the remaining two angles is 20 degree, since the total sum is 180 degree, if this is 160, sum of OPR plus ORQ is 20 degree, and since both of them are equal, each one will be 10 degrees. So angle OPR is 10 degrees. In figure, angle ABC equal to 69 degrees and angle ACB equal to 31 degrees. It is given here. We need to find BDC. We need to find this angle. Now we see that from BC is the common chord. So angle A will be equal to angle D. by theorem. So if we can get angle A, then we can find angle BDC. What is angle A? In triangle ABC, this is 31 degree, this is 69. So this will be, total sum is 180. So sum of these two is 100 degrees. So this will be 80 degree. Angle A will be 80 degree. So angle D also will be 80 degrees. In figure A, B, C, D are 4 points on a circle. AC and BD intersect at point E such that BEC, this angle is 130 degrees, and angle ECD, this is angle 20 degrees. We need to find BAC, this we need to find. Now we see that if this is 130 degree, can you tell how much will this will be? This will be 50 degree, linear pair. So if this is 50, this is 20, what will be the angle D? This sum is 180, 50 plus 20, 70, 180 minus 70. So angle D will be 110 degrees. Now consider BC as the segment. So it is subtending an angle 110 degree at D. Similarly, it will same segment will subtend at any other point on the circle, same angle. So angle A will be equal to angle D equal to 110 degrees. In this problem, ABCD is a cyclic quadrilateral whose diagonals intersect at point E. If DBC, this angle is 70 degrees, this is 30 degrees. We need to find BCD first. BCD first. So it is, now consider this DC as the segment. So it is subtending an angle 70 degree here. So similarly, it will subtend here also 70 degree. So this angle also will be 70 degree because angle in the same segment are equal. DC is subtending angle 70 degree here and also an angle 70 degree here. So this triangle 70 degree and also this triangle, this will be 70. So now the sum of the angles, opposite angles in a cyclic quadrilateral is 180 degrees. So 70 plus 30, this is 100 degrees. So this angle will be 80 degrees. So that's what we got, 80 degrees, BCD equal to 80 degrees. Now we need to find angle ECD. ECD, this angle we need to find. Total angle is 80 degree. Now it is given that AB equal to BC. So ABC is an isosceles triangle with these two sides being equal. So if this is 30, this angle will be 30. BCA will be 30. If BCA is 30, the balance is 80 minus 30, so 50 degrees. So ECD will be 50 degrees. If diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is a rectangle. We need to show that ABCD is a rectangle. It is given that ABCD is a cyclic quadrilateral. Diameters of the circle through the vertices of the quadrilateral. The diagonals of this cyclic quadrilateral are the diameters of the circle. It is given. Now we can easily show that BAD, so DB is the segment, so BAD will be half of 180 degree. So half of 180 degree is 90 degree. We can show that BAD is, this angle is 90 degree. Similarly, angle A plus angle C is 180 degree. Cyclic quadrilateral. Opposite angle sum is 180 degree. Angle C will be 180 minus 90, which is 90 degree. Similarly, we can show that angle B is 90 degree, which is half of angle AOC, which is 180 degree. So this is 90 degrees. So opposite angle sum is 180 degrees. Angle D also will become 90. So all the four angles are 90 degree. So it is a rectangle. In this problem, if the non-parallel sides of a trapezium are equal, trapezium is the two sides are parallel, so AB is equal to CD. The non-parallel sides are equal, so AD equal to BC. We need to show that it is a cyclic. Cyclic means opposite angles, we can show it sum as 180 degrees. Now we draw a line AM perpendicular to DC and BN perpendicular to DC. Now compare these two right angle triangles. where AD equal to BC, one angle is 90 degree, AM equal to BN, this perpendicular distance between two parallel lines is same. So these two triangles are similar. So by CPCT, ADC, ADM will be equal to BCN. So these two angles are equal. Now angle BAD and ADC are on the same side of the transversal. BAD and ADC. So this angle plus this angle sum is 180 degree. But this angle is equal to this angle, already we have seen earlier. So angle BAD plus angle BCD is equal to 180 degree. That's what we have written here. This equation proves that the sum of opposite angle is supplementary. Supplementary means 180 degree. So ABCD is a cyclic quadrilateral. In this problem, two circles intersect at points B and C. Through B, two line segments ABD and PBQ are drawn to intersect at point ADPQ respectively. It is given here, these are the two circles. Through the intersection, we have drawn two lines ABD and PBQ. We need to show that ACP is equal to QCD. These two angles which are marked, we need to show equal. Now we see that ACP and ABP are in the same line segment. So this is the one arc, let us see. So it is subtending an angle here, this angle. Similarly, this arc is subtending this angle also, PBA. That's what we have written here. ACP and ABP are equal. ACP and ABP are. Similarly, we can show QCD equal to QBD. QCD it will be equal to QBD in this arc QD. These two angles are equal. So from these two, we can show that QBD is equal to ABP. QBD is equal to ABP. These are vertically opposite angles. So hence ACP is equal to QCD. From these two relations, we can show that ACP is equal to QCD. If circles are not taking two sides of a triangle as diameters, prove that the point of intersection of these circles lie on the third side. So ABC is a triangle. So from the first side AB, we draw a circle with diameter AB. Similarly, AC is another side through which we draw a circle with diameter AC. Now we need to show that the intersection of the two circles is at the third side of the circle BC. So we need to show that D lies on BC. If D lies on BC means BDC is a straight line. We need to show that. Now angle in a semicircle is right angle. So AB is a ABD. This is a semicircle. So angle subtended by the semicircle. So this angle is 90 degree. Angle ADB is 90 degree. Similarly, AC is the diameter of the circle. It is subtending an angle 90 degree here. So angle ADC is also 90 by theorem. So sum of these two angles is 180 degree. So we see that BDC is a straight line. ABC and ADC are two right angle triangles with common hypotenuse AC. These two angles are given as 90 degree. We need to prove that CAD angle is equal to CBD. Now consider this triangle ABC. This is given as 90 degrees. The sum of the remaining two angles will be 180 minus 90, which is 90 degree. Similarly, if we consider this triangle, this is 90 degree. So this angle plus this angle will be again 90 degree, sum of these two angles. So now we add these two angles from 1 and 2. Just we add that, we will get angle A plus angle C as 180 degrees. Sum of these two angles, angle A plus angle C, equal to 180 degrees. That's what we got. So So what does it mean? If angle A plus angle C is 180 degree, it means it is a cyclic quadrilateral. That's what we have shown here. ABCD is a cyclic quadrilateral. All the four vertices will lie on the circle. Now consider chord CD. Let us take the chord CD. So it will subtend angles CAD and CBD both being equal. So that's what we wanted to show, angle CAD equal to CBD, because angles subtended by the chord are same value. So the angle CAD will be equal to angle CBD. Prove that a cyclic parallelogram is a rectangle. Let ABCD be a cyclic parallelogram. ABCD is a. Now angle A plus angle C is 180 degree, opposite angles of a cyclic quadrilateral. We note that the opposite angles of a parallelogram are equal. So this plus this is 180 degree, and these two being equal, so angle A will be equal to angle C equal to 90 degree. Similarly, we can show angle B will be equal to angle D equal to 90 degree. So all the four angles are 90 degree. So it is a rectangle. Friends, with this we conclude this video. Please like and subscribe my channel so that future videos can be released to you instantaneously. Thank you very much, friends.